This question belongs to algorithm subject and was asked in GATE 1990. So the question states, match the pairs in the following questions. So we have been given some algorithm in the list 1 and we need to match whether there are greedy, dynamic programming, divide and conquer or depth first search. So the algos are Strassen's matrix multiplication algorithm, Kruskal minimum spanning tree algorithm, Biconnected components algorithm and Floyd shortest path algorithm. So let me first explain you what is Kruskal minimum spanning tree algorithm. So first, what is a spanning tree? A spanning tree is basically a subgraph of a graph which has all vertices of the graph. It has all vertices. Number of edges in spanning tree equals to number of vertices in spanning tree minus 1, and it is a tree, which means it is acyclic and connected. So let me draw a spanning tree so that you can get it more clearly. So suppose this is a graph. So what is a spanning tree for this? Spanning tree, it will have all the vertices. It will have number of edges equals to number of vertices minus 1, which means 3 edges. And it should be acyclic. So like this it will happen. We can have various spanning trees. Now what is the minimum cost spanning tree? If we have cost associated with these vertex edges, then what is the minimum cost that we can get for a spanning tree? Like for this one, cost would be 10, 20, 30. So total cost is 30 plus 2, 50 plus 10, 60. Total cost is 60. And if we have another spanning tree like this, we can have various spanning tree for this. But for this, the cost will be 40 plus 10, 50 plus 2, 20, 70, 70. So if we have various spanning tree, what is the minimum cost? So this can be done using Kruskal algorithm. So what Kruskal does is, it is based on greedy method. So what greedy method states? We will look at the choice which is best suitable at a present point of time. So we make it greedy by assuming that we will always take the minimum cost. We'll always take the minimum cost, first 10, then 20 and then 30, and by doing so we will also avoid the cycles. If a minimum cost is making a cycle, we will not take it and take the next minimum. So this is the Kruskal algorithm. So Kruskal is related to greedy method, option B. Now let us see the next option. So the next option says bi-connected component. So what is a bi-connected component? Suppose we have a graph given. So a bi-connected, option C, bi-connected component. So if we have a graph G, then a bi-connected component is a maximal bi-connected graph. All maximal bi-connected graph is called the bi-connected components. And what is a bi-connected graph? A bi-connected graph means that a graph is called a bi-connected graph if among all the vertices there exist two vertex disjoint paths, means no vertex should be common in that path. And this bi-connected components can be easily done by DFS algorithm, as we just need to make a scan and make sure that no vertices are repeating, and in that case we will get a bi-connected component and a bi-connected graph. Now the option D is Floyd shortest path algorithm. So Floyd is basically all pair shortest path algorithm. Let us suppose we have a graph like this and it may be connected like this. It will have various costs like C1, C2, C3, C4, C5, C6. So we need to find out if we start from this vertex V1. So what is the minimum cost in which we can reach to V2? We can go by C1 or by C6, C5, C3 or by C6, C5, C4, C2. So what is the minimum cost to reach? And we need to find it for all the pairs, like for V1, V2, V3, V4, V5. What is the minimum cost to reach V1, V2, V3, V4, V5? So it's basically done using dynamic programming. I will give you the link which you can refer for the code for dynamic programming for this Floyd version algorithm. So Floyd version is based on dynamic programming. So this is the link. You can refer to this link and you will get to know how it is related to dynamic programming. It's a Geek for Geek link which tells Floyd version algorithm DP solution. Now let us see the next option A. So what is option A? Option A is Strassen's matrix multiplication. Suppose we have two matrices M1 and M2 of size M cross N and M2 of size N cross P, and we need to multiply them. So what is the complexity? So if we do by 3 loops, then the complexity will come out to be order of n cube. But we have a better solution. Suppose we divide A into 4 parts A, B, C and D of size n by 2 and n by 2. This is n by 2 and this is n by 2. So all A, B, C, D have sizes n by 2 and n by 2. And E, F, G, H also have sizes n by 2 cross n by 2. Now we have these 7 predefined formulas. We need to remember them. Here each A, B, C, D, E, F, G, H is an n by 2 cross n by 2 matrix. And if we do perform these operations, then we will get the resultant matrix which is of size n cross n for the multiplication. So let us count the number of multiplication and addition. Here let us count the additions. So 1, 2, subtraction can also be counted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 18 additions. Let us count the number of multiplications. 1, 2, 3, 4, 5, 6, 7. We have 7 multiplications. So what will be the complexity? And the size of each of the matrix which is being multiplied is n by 2 cross n by 2. And size of each of the matrix being added is n by 2 cross n by 2. So the complexity is 7 additions 70 n by 2 plus 7 multiplications and 18 addition of n by 2 matrices of the size 18 n by 2 square. So the complexity will come out to be by Master's theorem order of n to the power 2.81. We can easily see it is based on divide and conquer approach. We are just dividing the matrices into smaller part. N cross n is divided into n by 2 cross n by 2, and then the smaller problem is being solved. Thus, Strassen's matrix multiplication is based on divide and conquer, which is R. So the correct mapping is RBSQ.